My name is Austin Stillwell, and this is my final project for Java Music Systems. My final project is an algorithmic music composition system that pulls data from the internet, specifically data from New York City, the weather and the traffic, and then it makes decisions based off of that data to control what kind of music it's producing. So this is the GUI that I have up here that I've made. It's called the Sound of New York. And basically, right now what you're hearing is the current traffic and weather for New York City. The weather on the right is currently just the temperature. And then the traffic is, there's actual traffic cameras that you can access the data from that tell you how fast the traffic is moving in specific areas around New York City. So that controls kind of the speed of the algorithmic music composer. So just to show you a couple things about it from the get-go. Everything's being controlled in this JMSL player.java, and it's all just being controlled via music jobs and a sequential collection and a parallel collection. If you look at this parallel collection, it calls up wQuery and tQuery, which those are my two query apps that are connecting to the internet and then asking the online APIs what the current weather and traffic is. And then it adds the mutator, which the mutator is getting all the data from wQuery and tQuery, and then it is making pitch decisions, duration decisions, and it's also making voicing decisions for my instrument. So it's an FM instrument, so there's a modulation index, there's a delay in there, so there's delay time and feedback percentage. And all of that data is kind of being decided by what's coming in from wQuery and tQuery. And then, let's see, the sequential collection just adds it all in the order that I want it to happen in. because I want it to go through the queries and then give that data to the mutator before I start my music shape, which then takes all the new pitch data and all the new data for the instrument. So it happens, I want it to happen in that correct order. So if we go to tQuery here, this is the traffic querying app. And basically all it does, it connects to this website here, and it gets the data from it. And if I undo this system out right here, we can actually look at the data that we get from it. It gives you this huge long list. And these up here tell you what the list is made of. So you get an ID number, a speed, a travel time, a status, data as of, linked, blah, 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 all this stuff. And all the way at the bottom here, you see what borough it is. And I'm using this parse for value string tokenizer, and then what it does is it's looking for these characters that tell it that that's how to parse the different pieces of data from. So it goes through all this data and it says, oh look, there's a quotation and a space here, so this is a piece of data, and then this is a piece of data, and then this is a piece of data. So then if we comment that back out and look at this is the tokenized parsed data, and it just gives it to you in a longer list of parsed out separated pieces of data points. And then so what it does is you say if a specific token equals, I'm giving it a number 1 because that first piece of data had a data ID of number 1, which ended up being, you know, some intersection in Manhattan. Let's see. The number 1 is, where is it? 11th Avenue in Gansevoort and 12th Avenue at 40th Street. So then it looks for that, and then it says it says next token twice because there's actually a space and then there's the actual miles per hour that happens at that. So then it says, if you see a number 1, then go to next, and then take that piece of data, and that is our traffic speed. Yeah. So that is what tQuery is doing. Where was the system out that I did? Did I already do that? Cool. And then it spits out a thing that says current traffic is 11.1 miles an hour. And then if you look at wQuery, it's doing very similar stuff. If we uncomment here, we will see the raw data that we're getting from wQuery. And it literally just gives you, I give it a coordinate of where I want the current weather, and then it comes back with the current weather. Maine is rain, light rain. And then it gives you the temperature and the barometric pressure and humidity. The difficult part about the weather is it doesn't always give you all of these points of data. It will only give you what's happening currently. So if there's rain, it will say there's rain, but if there's no rain, then the rain thing doesn't show up. So it's not like I can query it and be like, when you see rain, what is the data value that it gives you if there is rain? So the difficult part of that is kind of making that data that it gives me into something that's useful. So the easiest way to do it was to literally just take the temperature, which is given to you in Kelvin. And then the barometric pressure is kind of a good indicator of whether or not a storm is on its way or not. So those are two indicators that always show up no matter what when you're querying it. Going on into the future, I would prefer to kind of pull other pieces of data and be like, if you see the word sunshine, then token, add 1 to the happiness index of the weather. And if you see the word rain, then subtract 1 from the happiness index of the weather. But that's something that I could do in the future. But yeah, so this is doing the same thing. It's using the tokenizer to split up the data into different sections, and then it's looking for the word pressure and the word temp, and then it's grabbing the next token after the word pressure and the next token after the word temp, and then saying this is temperature and this is pressure. And then if you look up here, it's spitting those values out. This is dtemp. This is me converting the Kelvin number into a Fahrenheit number up here. So that's what wQuery does. And then I port all that data into Mutator, which is similar to the mutator that we were talking about in class. And it is taking all that data and then kind of converting it into an index of general happiness and general speed of traffic. And then it's saying, I split those values in between 0 and 1,000, and I split 0 and 1,000 into 3 basic chunks. So 0 to 332, and then 333 to 660, what, 2. And then I split it into thirds, and then I say if you're in the bottom third, then you're slow. If you're in the middle third, then you're medium, and if you're the top third, you're fast. And then if you're for the weather, if you're in the bottom third, then you're sad. If you're in the medium third, then you're medium. If you're in the top third, then you're happy weather. And I send all that to these if statements. And those are the ones that are saying, yeah, if T-bar, traffic bar value is less than or equal to 333 and greater than 333 and less than 665, then I set duration values and I set different values. I send different values to my music shape. Like this, I think 5 is, let's go to the music shape and find out. Getting this up later. 5 is delay time. Yeah, so we're setting delay time, we're setting duration, we're setting, I think, feedback percentage, all based off of this is traffic speed. And then also for the notes, which is related to the weather, if I'm happy, then I set note weight 2, 3, and 4 to 10, 5, and 0. And then I'm also, I think this number 6 data point on my music shape is the modulation index. So I was like, if it's happier, then the modulation index is lower and the sound will be less weird.